why are we here? I mean, that's gotta be one of the biggest questions anyone can ask, right? But today, we're not gonna get philosophical. We're gonna talk physics. Because there's this incredible idea that the answer to why life even exists is written into the most basic, fundamental law of the entire universe. So let's just put it out there. Was life a complete and utter fluke? A one in a trillion shot that just happened to work out on our little planet in an otherwise dead cosmos? Or was it always going to happen, as long as you had the right ingredients? Well, this whole explainer is about a fascinating, mind-bending idea that life wasn't an accident at all. It was a direct consequence of physics doing what physics does best. Now, to get to that answer, we have to start at the beginning. I mean, the real beginning. Before we can even talk about biology, we've got to understand the one physical law that pretty much runs the whole show, the universe's one and only driving force. And this is it, the second law of thermodynamics. Now, I know, it sounds super complicated, but the core idea is actually really simple. The universe, at its heart, is kind of lazy. It always wants to spread energy out, to go from a hot, concentrated state to a cold, dispersed state. Think about a hot cup of coffee on your desk. It doesn't get hotter, right? It cools down, spreading its heat into the room. It is a one-way street, always. Okay, so this chart here really lays it all out. On the left, you've got things that are ordered and packed with energy. A star, a fully charged battery, you get the idea. Scientists have a term for this order. They call it low entropy. On the right, you've got the opposite, disorder, spread out energy, or high entropy. And the universe is just fundamentally compelled to push everything from the left column over to the right. It's its one and only job. So, what does any of this have to do with life? Well, let's hop in a time machine and go back about 4 billion years. The early Earth was a place that was basically an offense to the second law. It was totally unstable and just packed to the brim with concentrated energy. And, I mean, just look at this. You had this ridiculously intense sunlight just blasting the surface. You had massive amounts of heat churning up from the planet's core. You had all these wild chemical imbalances and super hot deep-sea vents. Earth was basically a giant battery, overcharged and practically vibrating with energy that needed to go somewhere. So from the universe's point of view, this was a mess, a real problem. All of this useful, concentrated energy was just sitting there, and it needed a way to spread out, to disperse. Sure, some simple, non-living chemical reactions were happening, but they were slow. They just weren't breaking down these energy pockets fast enough. The second law needed a better tool for the job. And this is where things get really interesting. To solve its energy problem, physics didn't invent some new law. No, instead, it just stumbled upon a process. You could almost call it a loophole that was just spectacularly good at creating disorder and burning through energy. So here's how it likely went down. In all that chemical chaos, somehow, a molecule forms that can do something amazing. It can make copies of itself. And here is the absolute key insight. The very act of copying, of building a new structure, uses up and spreads out energy. So when one replicator becomes 2, and 2 become 4, and 4 become 8, you've accidentally created this incredible engine for increasing entropy. From the universe's perspective, this is a fantastic solution. And naturally, any replicator that gets better at this job, copying faster, using energy more efficiently, is going to be favored because it's doing the universe's work better than its neighbors. Just let that sink in for a second. This is literally survival of the fittest, but we're not talking about animals or plants. We're talking about simple molecules. Biology isn't even a thing yet. The fittest here isn't the strongest. It's the structure that is the absolute best at dissipating energy. It suggests that natural selection isn't just a rule for life. It's a fundamental principle of physics itself. And this process, this relentless, physically driven race to find better and better ways to dissipate energy, it doesn't just stop. It builds on itself, growing more complex, finding more and more intricate ways to structure matter, all for the purpose of burning through those energy gradients more efficiently. And what's the ultimate result of this process? What's the most sophisticated, complex, and beautiful energy-dissipating machine we know of? It's life. This one sentence just hits the nail on the head. It's the core of this whole idea. We usually think of life as this amazing force for order, fighting back against the universe's tendency to decay. But this view just flips that completely on its head. Life isn't fighting the second law at all. It's the most effective tool the second law has ever come up with. A single bacterium, a forest, an entire ecosystem? What are they all actually doing? They're taking in high-grade energy, like sunlight, and converting it into low-grade waste heat, spreading it far and wide. We are entropy machines. So from the cold, hard perspective of physics, we aren't a miracle. We're a solution to an energy problem. So that's a pretty humbling way to look at ourselves. But it also leads to a pretty challenging final question. If life was selected for because it's so good at this one job, what happens if something else comes along that's even better at it? Because this is the bottom line. This is the rule that's been driving everything. The fundamental force is efficiency. Physics doesn't care about DNA or feelings or consciousness. It simply favors whatever structure is best at taking concentrated energy and spreading it out. That's been the name of the game since the very first replicator molecule. Which brings us right here to today. What are we as a species building at a frantic pace right now? What new invention is designed to consume absolutely massive amounts of concentrated electrical energy and convert it into processing and an enormous amount of waste heat? Yep, AI data centers. On a pure energy per second basis, they are becoming unbelievably efficient engines for dissipation. And that leaves us with this final, maybe unsettling question. If the grand story of the universe is just a relentless search for better ways to increase entropy, are we just a phase? A biological bridge between simple chemistry and whatever comes next? A future silicon-based system that can do the universe's job even better than we can? It's definitely something to think about.